Hello guys, welcome to our geometry lesson, and today we continue last lesson topic regular polygon, and second topic is inscribed and circumscribed quadrilateral. You will be able to know the relation of radii of inscribed and circumscribed circles, know the inscribed and circumscribed quadrilaterals, and solve problems related to this topic. Okay, key terms for this lesson: polygon, regular polygon, inscribed, circumscribed, and quadrilateral. Let's review this information. We know that sine alpha, if here we draw an alpha, sine alpha will be opposite side over hypotenuse. It will be A over C. And here cosine alpha is adjacent over hypotenuse. Adjacent is B and hypotenuse is C. And the tangent alpha is opposite side over adjacent side. It will be A over B. And cotangent is adjacent over opposite. It will be B over A. Okay, next. Formulas for the radii of inscribed and circumscribed circles. Okay guys, look at this figure. Here AB, segment AB is the A, length of a side of a regular polygon. And here OH will be radius of inscribed circle. And the OA and the OB will be radius of circumscribed circle. And here HP is equal to A over 2. And then angle AOB is central angle. We know from the last lesson that measure of central angle will be equal to 360 degree over n. Here n is the number of sides. Okay, next. Triangle AOB is isosceles and the OH is its ape. So measure of angle HOB is equal to central angle over 2. And if we divide central angle by 2, we will have here 180 degree over n. And from this information we can write here 180 degree over n. And then in the right triangle OHB, tangent of angle HOB is equal to opposite side over adjacent side. And here OH is radius, yes? Radius will be equal to HB over tangent of angle HOB. And the HP here A over 2. If we put from these two terms meanings, we will have here this formula. And next, sine of angle HOB is equal to opposite side over hypotenuse. HP is opposite side and OB is hypotenuse. We know that OB is equal to radius of circumscribed circle. And from that, radius will be equal to HB over sine of angle HOB. And if we put the meanings of these two terms, we will have here the second formula. Okay, please write these two formulas and learn them. Example number 1. One side of a regular hexagon is 10 cm. Hexagon means 6 sides. Find the radii of its inscribed and circumscribed circles. Okay, let's look to solution. If we use our formulas, yes, we can find our answer. And here A will be equal to 10 cm. A means length of a side of a regular polygon. And n is the number of sides, yes? And if we put this information to the formula, our radii will be 5 multiplied by 103 cm and 10 cm. The inscribed circle of a square has radius 203 cm. Find the length of one side of the square. If we use formula, we must find here a. Radius, we know that 2 multiplied by 3, and the n here will be 4. And if we put these meanings to this formula, here will be our answer. Yes, a is equal to 403 cm. Okay, inscribed quadrilateral. A quadrilateral is called an inscribed quadrilateral if all of its vertices lie on the same circle. In the figure, ABCD is an inscribed quadrilateral. Okay, property. Before that, look at this information. This is inscribed angle alpha, and the AC will be double alpha. Yes, we know this information from last lessons. If we mark here alpha and here beta, the measure of arc ABC will be 2 alpha, yes, and the measure of arc ADC will be 2 beta, and the 2 alpha plus 2 beta will be equal to 160 degrees. And if we divide both sides by 2, here will be alpha plus beta equal to 180 degrees. From this information we can say the sum of the measures of A, the pair of opposite angles of an inscribed quadrilateral, is 180 degrees. Write this formula to your notebooks and learn this. Example number 3. ABCD is an inscribed quadrilateral with measure of angle A 70 and the measure of angle B is 100. And we must find the measure of angle C and the D. If we use property from the last slide, we can find this easily, yes? Here will be measure of angle C is 110 and the measure of angle D is 80. Example number 4. In the figure, ABCD is an inscribed quadrilateral with measure of angle A 4x minus 5 and measure of angle B is 5x plus 10 and the measure of angle D is equal to 3x plus 10. Find the measure of angle C. Okay, if we use the property, first we find measure of x. How we find? We just add two opposite angles and equalize to the 180 degree. And then we just solve this equation. X is equal to 20. After that, we know that measure of angle A plus measure of angle C will be equal to 180 degree, and we don't know the measure of angle C. And here, if we put this x 20, here will be measure of angle C is equal to 105 degree. Circumscribed quadrilateral. A quadrilateral is called a circumscribed quadrilateral if all of its sides are tangent to the same circle. In the figure, ABCD is the circumscribed quadrilateral. Points E, P, T, and S are points of tangency. Okay, property. The sums of the lengths of the opposite sides of a circumscribed quadrilateral are equal. In the figure, ABCD is an inscribed quadrilateral. AB plus CD will be equal to BC plus AD. Example number 5. 3 consecutive sides of a circumscribed quadrilateral measures 9, 12, and 13 centimeters respectively. Find the length of the fourth side. Here's the illustration. If we use the property, 9 plus 13 will be equal to 12 plus x. From that, here will be AD is equal to 10. That's all, guys. look at this website and you have good practice from your book. Thank you for watching. Goodbye.